Okay, so now we have introduced how to estimate population mean when you know the population variance. Of course, sometimes you don't have that. So now let's talk about how may we estimate population mean when we do not have the population variance. So sometimes, or actually for most of the time, we do not know the population variance. Okay? In that case, we will not be able to calculate the standard error. We will not be able to calculate that. And you probably still remember that this particular standard error is used when you calculate the lag length. So if you don't have that, then you don't have a confidence interval. In this case, when you do not have the population standard deviation, intuitively we may try to replace sigma by S, the sample standard deviation. For example, for that 7 values we obtained in our example, we can actually first calculate the sample mean, and then use the formula for sample standard deviation to calculate the sample standard deviation. Okay? So the sample standard deviation is around 140. We then probably want to use S over square root of n to construct an interval. However, we can know that this would be wrong, would be misleading. Why? Because this is not right. We will not say that the sample mean follows a normal distribution whose standard deviation is S over square root of n. One particular way to understand that is wrong is that S is actually a random variable before you really do the calculation. From sample to sample, your S would be different, right? So it won't be possible for S over square root of n to be the standard deviation of your sample mean because it's not even a constant. So obviously we want to follow the same idea, but we need to do some adjustments. And the adjustment is here. Instead of relying on a normal distribution, now it's time to introduce a new distribution to you. We're going to introduce you the t distribution and use it to do our estimation when we do not have the population mean. So technically, let capital S be our sample standard deviation, which again is random before you do the sampling. Okay, this is the standard deviation of the sample values you obtain, which would be random before the sampling. And the small s is the realized value. When we replace sigma by s, we have the following fact or the following theorem. Suppose our population is normal. Then this particular quantity would follow a t distribution with degree of freedom n minus 1. Okay, so now we have a lot of technical terms. Let's explain them one by one. So first, if you have a random sample, you will be able to calculate the sample mean, the sample standard deviation. Before you do the sampling, you actually know that these two guys are random variables. Okay, so if you put them into this formula, again, it's a random variable. So you know with some probability you are going to get this value, with some probability you are going to get that value. The value may be different from sample to sample. Okay, so this formula gives you a random variable. Let's call it capital T with a subscript n minus 1. Okay, anyway, it's a random variable. If it is a random variable, then it has a distribution, a probability distribution, right? If it is a random variable, it has a probability distribution. Fortunately, there were some statisticians, they found the distribution. Okay, they found what's the probability density function of the particular distribution. Okay, This is very complicated. We have x bar, which is random. We have capital S, which is also random. But according to this formula, we can write down its PDF. We don't need to know it in this course because eventually we will use software to do all the calculation. But the concept is that for this particular random thing, we know its distribution. We know its PDF. And then we call it the T distribution. The T distribution. There is a PDF. You don't need to know it, but you know there is a PDF. Okay? And then for all those random variables whose PDF is that PDF, we call them the T distribution or a T distributed random variable. Okay, the only parameter that decides the distribution is called the degree of freedom, which is n minus 1. N is your sample size. So that means when you have different sample sizes, the distribution of this particular quantity would also be different. Okay, so when you have different sample sizes, later you are going to need a different parameter to input into your Excel or whatever software function. In general, if capital X follows the T distribution with a degree of freedom n minus 1, then we use this notation to do the notation. It says capital X follows a T distribution with degree of freedom n minus 1. Okay, let's see how to use it to do our estimation. How does a T distribution look like? The T distribution is symmetric, centered at 0, and look like a bell-shaped curve. Different degree of freedom would give you a different T distribution curve. Okay, like in this graph, we depict the T distribution PDF with n equal the degree of freedom equals 5, 10, or 15. You can say that when n goes up and up, the distribution gets more centered, okay, close to the center. One thing we can tell you is that when n goes up and up, the T distribution would gradually approach the standard normal distribution. You can see that the T distribution looks quite similar to a standard normal, right? And when n approaches infinity, T distribution would be so close to a standard normal distribution. So eventually we will show you that T distribution will be used to replace your normal distribution in doing the interval estimation. Okay, so let's continue. Okay, let's try to apply the T distribution to do our estimation. Again, just a review. Before you do the sampling, you know you will get a sample mean capital X and a sample standard deviation capital S. You're going to use these two values to do an estimation. The thing is that given any B, which is your lag length, we are going to construct again an interval whose center is the sample mean and the lag length is B. Okay, again, we still want to calculate what's the probability for your mu to be within your proposed interval. Now, that's our target. Now we do not know the distribution of x bar. Okay, we do not know the distribution of x bar, so we cannot do the calculation directly. A good thing is that we know what's the distribution of x bar minus mu divided by s over square root of n. We know what's the distribution, so our formula would be changed in this way. I want to do this calculation, right? So I switch the terms. I want to know what's the probability for capital X to be within B from mu. Okay, I want to know that. And then I minus all these sides by mu and divide all these sides by s over square root of n. If I do that, then the center part here goes to my T distribution random variable, and I have the two sides here. so that once we obtain S, we plug in, we will be able to calculate the desired probability because we know the PDF of T. Then software would be able to help us. Okay, so for example, suppose I now do not know the population variance of that 3000 store example. What we know now is only the sample mean is 960 and the sample variance, sample standard deviation is around 140. Then let's assume I want to propose the interval, which is from 860 to 1060. That means I want to choose a leg length to be 100. Then what I want to do is to first understand that my n is 7. That means I have a t distribution whose degree of freedom is 6. Okay? With this, I know which PDF or which random distribution that I will be dealing with. And also I need to find the lower bound and the upper bound. All I need to do is to plug in those values I choose or the values I obtain. This is 100, B is 100, S is my sample sample standard deviation, and the 7 is my sample size. Putting all these numbers here and there, we will be able to find that the t distribution tells us the probability for me to be correct would be around 90%. Okay, where the last step can be done with any statistical software. All you need to do is to tell him that you are talking about a t distribution with degree of freedom 6 and you want to calculate this probability. Then the software will tell you is 89%. So we are 89% confident that the average number of daily customers would be within 860 and 1060. So the basic idea, as you can see, is the same. Okay, it's just that instead of relying on the distribution of x bar, we now rely on the distribution of t, the distribution of x bar minus mu divided by s over square root of n. Okay, that's the only difference. Thank you.